So I have the benefit of going to a lot of sustainability conferences just like this one. And more than a few times I've heard other speakers talk about net zero design and the future of a net zero economy, a carbon neutral United States. And the same guys, the Kennedy talked about in 1962, we choose to go to the moon. Right? They talk about it as this almost Herculean task that with enough might and resolve and technological innovation, it can be achieved. I think that's completely wrong. For two main reasons. Number one, it's not like Kennedy said in 1962, we're going to go to the moon. He had no idea how we're actually going to get there. Right? 7 years later, we did it. And no idea how when he said that. We already know how to do net zero buildings. It's not an impossible task. It's not an unknown. We know how to do them. The impediment is financing, if that's what we're going to focus on today. And secondly, technology is not the solution. Because we have really every technology we'll ever need to design net zero buildings available today. To make this happen will require a recalibration of how we design, build, finance our projects, but also most importantly, how we really begin to engage with one another, almost as a species, right? Net zero design is not a myth, it's not a unicorn, it's not the Yeti that someone sees every now and then in the forest with the right kind of equipment. It's very real and very possible. So we're going to explore today a range of financing solutions that can help us get there more quickly. I think part of the issue is even the term net zero energy. When we say net zero energy to many lay people, they say, well, that's actually quite, it sounds impossible, and it actually is. Buildings will always need energy to run. Carbon is the issue, except it's a little bit trickier. On the left, we have an artist installation from Copenhagen in 2009, where they visualized a metric ton of CO2, which is actually 25 feet square. Right? It has a real size to it. The average American is responsible for 18 tons per year. We grouped everyone's cubes over a single year. We have a volume 25 feet high, the size of the state of California. In New York, we're extremely energy efficient, tiny GHG footprint per capita per resident. But even so, over the course of a single day, that's a whole lot of blue cubes. So again, I think the refocus needs to be on carbon and carbon neutrality, and not net zero energy, because energy is not the problem. We'll always need energy to run our buildings. So let's bring this back to the built environment and buildings. That's why we're here today. This is a graphic we developed, which really conveys that thought. That today, even our most sustainable, most green buildings, perhaps the LEED Platinum projects out there, if they're really good, maybe they'll hit a 50% energy reduction, 60%, 70%. If we hit a 70% energy reduction, we're still putting out a whole lot of pollution, just less so. So again, we're today operating in the zone of the orange, the doing less harm zone. I think a lot of folks here are pretty excited to get to that next area, the green, sustainable or net zero design, living building design. No cubes, right? The idea that my project, my building, my company's not going to offset any carbon, I'm not going to bother the environment, it won't bother me, we have a form of stasis. That's not quite good enough because we've had 50, 75 years of building the other way. And so the future really is regenerative, restorative, net positive design. Which is not only will my building not emit carbon, but I'm going to take care of yours as well. And that building over there was built 5 years ago, and that one over there. That's what needs to happen. The majority of building stock in the US today, and New York is here. It's here to stay. So the focus cannot just be on new construction, but how are we going to go back and start to address our entire building stock and make it carbon neutral. I think part of the problem is that too often green design is thought in a very similar fashion as this picture of nature, which looks quite natural, but trees actually don't grow in a straight line like that, particularly not with one species, right, say one after another. So this is actually artificial nature, contrived nature, and I think in a lot of ways that's how we've been designing buildings today in many of our net zero buildings. I think this leads to simplicity, fragmentation, vulnerability, and higher costs, because you're not locating synergies. Everything becomes, in a sense, additive. Even if you bring us back to that prototypical American lawn, that's really expensive to maintain and keep it looking like that. So let's talk about an island for a second. This is one of those fun new man-made islands in the Middle East. Right? They have a giant machine, they start shooting sand, and all of a sudden you have an island. There's a reason most of us don't live on islands by ourselves. It is quite hard to survive on your own. Now, you could probably build enough things on that island to be self-sufficient, but it would probably be really, really expensive. In the same manner, developing solutions for a net zero project and only looking for available assets, either A, within your four walls, or B, within your legal site boundaries, well, it's bound to be more expensive because nature doesn't work that way. Right? It's full of virtuous cycles. The output of one informs the input of another, and those cycles only create value over time and add value to the system. And there's no such thing as a property line in nature. So how can we really have in our projects if we're really talking about net zero, net positive design? Someone who said this kind of best is Carol Sanford, an author, entrepreneur, business consultant, that there is a clear and distinct difference between doing less harm to an ecosystem and in fact belonging to one. So what does that actually mean for design, for buildings, for the built environment? The future of net zero, and I apologize for the fonts, a lot of them have shifted. The future of net zero does not look like a monoculture. It's a whole lot messier. But through that messiness comes diversity of connections, resiliency, and you're finally able to locate the cost synergies that can make net zero design affordable. I think this image on the screen also really embodies this notion of virtuous cycles. Let's take the tree, for example. It starts to grow, takes up resources, sun, water, soil. Hopefully lives a long, healthy tree life in the forest somewhere. It dies, falls down, and just adds nutrients back into the system for another tree. Even in death, it adds value. How can our buildings operate the exact same way? So this is an example of what a net zero or net positive energy flow might look like. Really trying to close the energy loop as tightly as possible. First, you want to identify what are your natural site assets. It could be wind, solar, geo-exchange. Next, you're kind of building and occupant available assets. And some of these quite clearly might be disguised as deficits. So that could be waste to energy, heat recovery. Again, you're really trying to close that energy loop as tightly as possible and support these self-propagating systems and in a sense run on their own. Again, how can the output of one become the input for another? In a sense, it just keeps on going. The ultimate goal is to reduce and almost eliminate the amount of energy you're pulling from the municipal grid. And being net positive, you're producing actually more clean carbon neutral energy than you'll ever need, and perhaps sharing that with your neighbor or selling it back to the grid. We're going to look at a few projects now from our portfolio. We completed this project about 2 years ago at the University of British Columbia. It was not only net zero, it was net positive. So we can look at about 2 years, 65,000 square feet, a living lab for sustainability research again on the UBC campus. And the humble goal was at a minimum to be net zero energy and water. And again, UBC is not a particularly rich university, it's a public university in Canada. So the first thing we did was try to identify what available assets might be on the site, near the site, around the site. And as I said before, often these are camouflaged as deficits or liabilities. So surrounding our building were a number of laboratories. Laboratories have things called fume hoods in them. They're constantly exhausting conditioned air because of the potential contaminants that might be within the laboratory. As a result, you're paying to heat or cool the air, and it's leaving your building really, really quickly. That building's incredibly expensive to run, and if you're in UBC or in British Columbia, you also pay a carbon tax, like in the EU, further adding to your costs. So we said, you know what, that's a deficit, let's turn that into an asset. What can we do with all that waste heat? And so on the left, we have the new project, and on the right, you can see highlighted just an example of one of those fume hoods. We installed heat recovery devices on every single fume hood throughout the entire campus. It takes that waste heat, takes the energy in it, the heat energy, sends it to a heat exchanger, then an absorption chiller, which can make either free heating or cooling energy. It's fed into the building, and so much is extra, it's put back out onto campus. Again, not only does this building produce enough energy to support itself, but also 40% more than it actually needs. And again, sends that free energy back out to the campus, which lowers their energy bill, as well as their carbon tax burden. Kind of made it happen. The process is actually quite simple, and we talked about it before. This is from another recent project in Southern California. We're going to take the baseline for that project type. Can we reduce it through passive design strategies? Probably a little bit. Red orientation, different types of fixed shading, and then look at technology to bring it down even further. The goal, as Michael said before, to bring that demand as low as possible, so it's actually possible to meet that reduced demand through on-site sources. We can develop a palette of potential renewable energy sources that can be applied to any site, depending on what's available. And for each one of those, looking at its availability, reliability, and cost. That's an important consideration for really every client. And for this particular project, a hybrid solution was most cost-effective, looking at wind, on-site waste to energy, and landfill gas. And in fact, the price they will pay for that blended energy source is cheaper than if they plug the building into the grid. Again, for that particular project, they couldn't give the name out to be confidential. The capital cost premium to be net zero, for a very large project, was just under 5%, which paid a 20% rate of return. Because that project would have paid more than $2 million per year in energy costs. Now, we got lucky with this client. The unfortunate thing is, and the number one reason we're not seeing more net zero buildings is because whether the cost premium is 1%, 2%, 5%, 10%, clients don't have the money. The budget is the budget. If I'm building a $100 million facility, you're telling me it's 1% more to be net zero, I don't have the $1 million. So that's the problem. Let's look at the solutions. Some of them are out there. It's not going to connect them to projects and clients. The majority of solar today is installed through third-party companies. Solar PPAs, they're called. They come in, put a panel on your building, they pay for everything, and then you buy that power back from them for the length of that contract, 10, 15 years, at a rate guaranteed to be lower than the local utility. The vast majority of solar today installed through PPAs. They're not doing it to be nice because they love the environment. It's extremely profitable. So let's take that a bit further. Why should they get all the business, right? So we're working with an engineering firm right now that does a lot of pro bono work. They have a new project in Haiti. They wanted to put a solar array on the project because unreliable grid in Haiti. The employees of that company are paying for the solar array for that project themselves out of their own pocket. They'll get the money back to utility payments from the client in Haiti over time. The intent on this project is not to make profit for obvious reasons, but applying this to the US makes a whole lot of sense. Crowdsource funding for renewable energy projects is the next frontier. So imagine a nurse investing in a solar array for their new hospital. Big hospital might have 1,000 nurses working there. Each one puts in $2,000. You got a $2 million solar fund. Should they do this because they care about carbon neutrality? Because they care about the environment? Maybe. But they're probably going to do it because it's a really good investment. It makes sense. Same with teachers, right? For parents in a new school, that new array might be $100,000. There's a great return on investment for it. There's crowdfunding investment. We're pretty close to kind of getting there. There are a few companies now in this market, but I'm 100% confident this is the future. And to take it one step further, imagine this audience investing their 401k contributions in a renewable energy financing project. We talked about it at my company. 401k, it's gone up and down the last few years. There's a pretty high degree of confidence, and instead we diverted that money to a large 1 megawatt wind turbine in the Midwest somewhere, less riskier, and probably more profitable than our current Charles Schwab account. Let's kind of make it happen. I'm very curious to see what the leaders in this room think about that money. I'm going to go a bit quicker. So this is another recent project currently on hold, Colombo, Sri Lanka, just southeast of India, lower bottom. A 500,000 square foot hospital, started in a sense by a bunch of investors. So this is not a nonprofit, this is not the government. They want to set this hospital up for medical tourism. They're business people. They want to make money. So the first kind of thing we struggle with is this dichotomy. In the sense, can you put a new world-class hospital doing surgeries in a place of unreliable energy, right, when the grid might go up or down? At the same time, what is our ethical duty for building this kind of fancy new world-class hospital in a heavily impoverished area? So on the right, pretty typical Colombo slum. People live next to, adjacent to landfills and trash. And that's actually one of the number one causes of disease in Colombo is waste. Human waste, so toilets, human waste, garbage, disease kind of everywhere. So we really looked at, is there an emergent solution that solves for both? In fact, it is. The hospital will start a company. The company will set up sanitation points throughout the entire city. In those sanitation points will be A, places to actually throw trash that's not someone's yard. B, toilets and showers. From those points, they're going to hire local residents to collect that waste, that deficit, which is actually free energy, take it to biodigesters, one at a major landfill, one at the hospital, make biogas, biomethane. All of a sudden you put that through a CHP engine, you have heat and electricity. So what have you done? You have clean, carbon neutral energy for this net zero hospital. It's extremely reliable. You reduce disease and provide employment opportunities for local residents. It just kind of works. Business case is there. And these are investors, not a nonprofit. I have a funny email from one of the project consultants standing on the site. I'll just read the last line. While this site may sound terrible, to him it's quite a wonderful site, because all that trash is free carbon neutral energy. And so again, it's about looking at what might be considered a deficit, a liability, often camouflage and such, and looking at how that can be converted to an asset used as the feedstock for another cycle. Probably go a few minutes over, but not too long. The hospital is also being designed to be a place of last resort. It's vulnerable to tsunamis, hurricanes, so it's being designed so residents can come there during a natural disaster and be safe. So I think that's actually a pretty key issue in how we're going to end today. So I think the question asked maybe of the speakers today, what is the cost of achieving net zero? It's an extremely important question, but I don't think the most important one. What is the cost instead of not achieving net zero? And I'm not talking about the intangible environmental or human health benefits, but what are the real financial risks for large companies, for our economy, for all industries, for not achieving net zero? So this is pretty groundbreaking. This is 3 weeks ago, May 19th, 2014. Maybe out of curiosity, who's heard of this lawsuit? My coworker back there, Farmers Insurance, a huge insurance company, on May 19th announced they were suing 200 municipalities across the country. And they said, A, you cities, you knew about climate change, you did nothing about it, a disaster hit, now we have to pay for it. Right? You're reducing value for our shareholders because you're not addressing this. This is only the beginning. I'm CEO of a major life insurance company. Health insurance. Right? According to the US government research, 50,000 early deaths each year because of air pollution. $150 billion in illness because of air pollution just in the US alone. Right? So I'm the CEO of a large insurance company. That's hitting my bottom line. I pay more if one of my shareholders or policyholders dies early. So I have to pay out, they haven't paid them enough, right? This is directly affecting the bottom line, and it's only going to increase in the future. So I think that's the real question we need to ask today. Again, not what is the cost of achieving net zero. So we can talk about that, and it's quite reasonable. But more importantly, what is the cost of not achieving it? I'll kind of end things on there. The Paul Hawken quote, my hero. He's famous for saying, our civilization needs a new operating system. We only have a few decades, but the fun part is we all get to be the programmers. It's really kind of that easy, right? Let's go to the moon together.